Okay, now with any approximation that we do, it's going to be exactly that, just that approximation. As long as the function is curved, that's what it's going to be anyways. So we're going to continue our study of approximating area under a curve, and this time we're going to use trapezoids instead of rectangles in each subinterval. So if you go back to geometry, and we've kind of talked about this in class, the area of a trapezoid is the height times the area of the bases times a half, okay? Or as you can see by my little area formula right here, you can take the height divided by 2, and then it's the sum of the bases. Going back to your geometry lesson, if you remember, the bases have to be parallel to one another. So in our example, this is actually the height of the trapezoid, and the first parallel side would be base 1, and the second parallel side would be base 2. Okay? So I'm just going to show, let's say the function to the right, we'll go from A to B, and let's just use 3 equal subintervals. And if you just take a look at the very first subinterval, let's just call this C, and we'll call this guy D. Okay? When you divide a region into trapezoids, you do the same thing, except for the left endpoint, you're going to use the function value. At the right endpoint of the subinterval, you're going to use the function value, and that will create the 2 parallel sides of the trapezoid, and then you just connect those 2 points, and that would be the first trapezoid. So we'll call that guy, for this case, T1. And you do the same thing with the second subinterval. This is going to look almost rectangular, but... And then for the third one, again, you use the height of the function at the left and the right hand endpoints of the subinterval, and that will create another trapezoid. Okay, so in this case, a trapezoidal approximation, you would just add up all of the trapezoids. So T1 would equal 1/2 the height, which would be C minus A, times the base 1, which would be f of A, plus the base 2, which is f of C. The second trapezoid would be 1/2. The height of the trapezoid in this case would be D minus C. And you would use the base 1, which would be f of C, and the base 2, which would be f of D. And then your third trapezoid, you would do 1/2 the width, the height of the trapezoid, which is going to be B minus D. So for all of these, for all of the heights, you're just talking about the difference in the x values. That's the height of the of each individual trapezoid. And then the base values is just the height at the left endpoint and the height of the right endpoint. Okay, if you add all those guys up, this would give you a trapezoidal approximation using 3 subintervals. Okay, so it just depends on how many subintervals you use, and it also depends on, well, actually, that's it. So, good talk. Okay, let's go ahead and take a look at an example with some numbers now. Okay, use a trapezoidal approximation method to estimate the definite integral. So again, you know, we're pointing out that we're estimating a definite integral of f of x. Here's our function from x equals 1 to x equals 7, and we're using 3 subintervals, and we're going to talk about, is the estimate greater than or less than the true value. So the first thing I'm going to do is I'm going to put all of those words into notation. So the first thing is we're approximating a definite integral. So here's our definite integral, and we want to use the bounds. The left limit is going to be x equals 1. The upper bound, or the right limit, is going to be x equals 7. Our integrand is the function f of x, and we're integrating with respect to x. Okay, so we're trying to approximate this, and we're going to use the trapezoidal with 3 subintervals. Okay, if you want to think about what this guy looks like, it's an exponential function. something like that. Here's 1 and here's 7. If we're talking about 3 subintervals and we're going to use equal widths, then the width of each subinterval, which in a trapezoid is actually the height of our trapezoid. You know, it gets confusing, but you know, it just depends on what shape you're using for your approximation. So the width, our delta x, which is the height of our trapezoid, is going to be 7 minus 1. That's our entire x region, and we're dividing it into 3 subintervals. So that gives us a value of 2. So we're going to use 1, 3, 5, and 7. Okay, so that's dividing it up into subintervals. If you want to draw the trapezoids, you are more than welcome to. It's not required, but a lot of you are visual people, so I'm going to go ahead and do that. The first subinterval is from 1 until 3. Okay, so I'm going to go use the left endpoint of 1, pretend that that goes through, and I'm going to draw a point. I'm going to go up at 3 and draw a point, and that would be my first trapezoid. Okay, so we'll go ahead and break it up, and we'll say that the first trapezoid is going to be 1/2. The height of the trapezoid we just said was 2. And then the left end point is going to create the first base, so that would be f of 1. The right end point creates the second base, so that's f of 3. Okay? And again, you can get those function values. This would be a calculator problem, so you can use your calculator to plug in and find these values. And you're going to do T2 using the interval from 3 to 5. So if you start at 3 and you go up, you've already drawn that one, but at 5, that would be the trapezoid there. 1/2, the height of the trapezoid is still 2. And this time our base 1 is going to be f of 3. Our base 2 is f of 5. And then you would do this same thing for your third trapezoid. 1/2, the height of the trapezoid. Base 1, bless you, Braden. Base 1 is f of 5. Base 2 is f of 7. When you add all of those up, that's going to give you your approximation.
What did you do?
So that is going to give us an approximation of 14.436. All right. And if you take a look at your assignment sheet and you look at which problems we're going to be doing based off of the worksheet and the trapezoid approximation, try a couple of the other problems, and we'll talk in class about what answers you should get. All right. So good lesson, everybody. Go team. And I almost forgot that we have to talk about whether or not this is going to be an over approximation or an under approximation. Hold on. Okay, sorry, minor technicalities. I'm just going to show you really quickly, and we'll talk about this in class. But if you have a function that looks like this, and you draw a trapezoid, and I'm going to make it a really obvious one, and connect this point to this point. Oh, that was awful. Let me try that again. This is really hard to do on the tablet here. I'll make it really, really, really obvious. If you connect this point with this one way up here, okay, connect that and make that a trapezoid, that is an over approximation of the true value. The line is going to be above it. And we're going to talk in class about when wouldn't that be the case. So, okay, have a good night. Bye.